Hello everyone. In this module, we have been studying functions that are derived from polynomial functions. Before this, we studied the rational functions, which are obtained by dividing a polynomial by another polynomial, right? In this video, we will study some other functions that are derived from polynomial functions by taking the powers and the roots. Okay, to make sure that we are caught well caught up on the basics, we will begin with some laws of exponents and then apply them to the study of functions. Let me begin here. In this table that you see here, we are going to write equivalent forms of some of these expressions. Okay, what is b to the negative 1? When you raise any number to the power negative 1, in laws of exponents that represents the reciprocal. Okay. In other words, when you take the negative exponent to the denominator, or when you change it from numerator to denominator, the negative exponent becomes positive exponents. 1 over b to the 1. Right? In the same way, b to the negative n is 1 over b to the n. Okay. Now, all of these are basics we have already studied in high school. I'm only reviewing here. If you want to do a more thorough review, please refer to any materials, resources on that topic, laws of exponents on YouTube, or general internet search, or just your plain high school math textbook. Okay. b to the power 1 over n. That represents a fractional exponent, which is another way of writing the radical expression, nth root of b. Okay, so the root, if you are taking a root, nth root, that appears in the exponent as denominator 1 over n. And now if I were to take a negative nth root, I can apply the two things that we just discussed, right? Negative exponent, so you can make it positive by taking it to the denominator. In the denominator, the 1 over n, exponent 1 over n is nth root. Okay. Similarly, you can take the nth root of a b which is already raised to a power m. Okay. So the m in the numerator here is raising b to that power, it increases the value, assuming, generally we are talking about large values like 2, 3, 4, and n takes the root of that. So the expression becomes nth root of b raised to the power m. Okay. Similarly, if you had a negative exponent, now that will go to denominator, 1 over nth root of b to the power m. Okay. That is about fractional and negative exponents. On the right side now, we look at some more laws, especially about when to multiply the exponents and when to add the exponents. Okay. If you have a number b raised to the power m and that whole thing is raised to the power n. Okay, that's what we mean there. That is b to the power mn. In that case, we can multiply those exponents. Okay. What you have to be careful here is note. Okay, I'll make a note here. B raised to the power m raised to the power n. If you did not have any parenthesis, that is different. That is not b raised to the power mn. Okay, that is called a tower. If you are interested again, you can learn online about this topic, towers, exponential towers. It is a fascinating topic. But for us right now, what I want to emphasize is, if you are raising b to the power m, the whole b to the m as a power, the power of b to the m, then you multiply the m and n, becomes b to the mn. Whereas if there is no parenthesis, then first you raise m to the power n, whatever number you get, b is raised to that power, and the values are going to be different generally. Okay, just to bear in mind the whether the parenthesis is there or not. Okay, that is about multiplying exponents. If you multiply two exponential expressions which have the same base, then you can add the exponents m plus n. Okay, and finally, if you raise any number to the power 0, that is equal to 1, only condition is that b is not 0. 0 raised to the 0 is not 1. Everything else raised to the 0 is equal to 1. Okay, and regarding that also I'll make a note here. 0 raised to the 0 is an indeterminate quantity. I'll not elaborate more on this right now. When necessary, we will talk about it later. Okay, that's called an indeterminate quantity. So it's not a number basically. You can think of it as not a number, something weird. Okay, anything else to the power 0 equal to 1. Okay, let us do these two problems. Evaluate the following radicals without using a calculator. And we will try to use these laws that we have discussed just now. Okay. 27 raised to the power 4 over 3. How can I do it without a calculator? Let me see. There is a denominator 3, so that is cube root, right? Cube root of 27 to the power 4. But if I want to now, let's say, multiply 27 times 27 times 27 4 times, and then take the cube root, that's, you can not in theory you can do it by hand, but that's not advisable, right? But we are not using a calculator. Then what do I do? I'm going to use the law of exponent, the other law of exponent that we studied. Okay, if we have taking the cube root of 27 to the power 4 is the same as first taking the cube root and then raising that to the power 4. Okay, to understand that more clearly, or if you think it's not clear to you, think of it like this. This is 27 raised to the power 1 over 3 raised to the power 4, right? And according to the law that we discussed up here, b raised to the m raised to the n, then you is b raised to the mn, right? You multiply those exponents. In the same way, 4 over 3 is 1 over 3 times 4. So you could have first taken the cube root. You can first take the cube root and then raise it to the power 4. That makes it easier because cube root of 27 is 3. 3 times 3 times 3 is 27. Okay, check it out. So the cube root is 3. So you are basically raising 3 to the power 4. So that is 81. You can check that. Okay, 3 times 3 times 3 times 3, which you can pair up and say 9 times 9, that is 81. Similarly, 16 to the power negative 3/4. So following our formula that we have written above, First you take it to the denominator because there is a negative exponent, right? And that's the fourth root of what? 16 cubed. So again, I'm going to do the same thing. I'm going to express this as fourth root of 16 cubed. And what is fourth root of 16? 2, right? 2 times 2 times 2 times 2 cubed. It's 1/8. Okay. So using the laws of exponents appropriately in a very smart way, we can evaluate without using a calculator. Okay. We converted from exponent form to radical form and simplified those expressions. Let us do some practice on the other way around, right? Given the radical form, we want to convert it to exponent form, and many times that is useful. Okay, as we will see shortly, x raised to the power, okay, so x square and fifth root of that. So that would be raised to the power 2/5, right? The root, fifth root becomes the denominator in the exponent. Okay, let us apply that and some other properties to do these problems. Y to the negative 3 and xth root of that. So by our laws of exponents, it will be minus 3 divided by x. But if you want to write it with a positive looking exponent, we don't know whether x is positive or not. But if you want to write this expression as a positive exponent, you would write 1 over y to the 3 over x. And there isn't much we can do about it. Okay, that is only a demonstration. Let's look at another problem. So you always try to see, what is a simplified form. There is no one particular answer, okay? And sometimes instructions will be clear that you write with a positive exponent. So in that case, the second form would be better, And if the instruction is write as an exponent and without a radical sign, then that is better. But if you have to write with a radical sign, then this itself is a good, final form. Okay, so we are not saying we are doing any simplification as such in that. We are only playing around about the equivalence of the radical sign and the exponents. But in the second two examples, you will see we actually make it simpler. Okay, for example, look at this expression. 4/5 root of 1 over x to the minus 10. That's even if you think about it, it is a complicated expression, right? Let us try to make it simple. You can do it in different orders, okay? I'm just choosing to do one way. That's not the only way. As long as you follow some law correctly, you will be good, okay? So first I wrote x to the 10 in the numerator because it is 1 over x to the negative 10. You change the side from denominator to numerator. You change the sign of the exponent, okay? Minus becomes plus. What else can I do now? I have the 4/5 root. So I can write as x to the 10 whole raised to 1 over 4/5, right? That is the meaning of nth root. Nth root is that quantity raised to the power 1 over n. Now you try to simplify it. X to the 10. Now you can multiply that, right? It's going to be 10 times whatever the other exponent is. And that I'm going to write as 5 over 4 after flipping it. Okay, 1 over 4 over 5 becomes 5 over 4. Is there anything I can do to simplify? Maybe something very minor. 10 and 4 both are divisible by 2. 2 times 5, 2 times 2. I can cancel those. And that's about it. There isn't much we can do. 5 times 5, 25 divided by 2. But that's much better, right? X to the 25 over 2 is a much better answer. Or if you want to write with a radical sign, square root of 2 after all is just the regular square root. Okay, when it is 2, we don't have to write it in that V shape, you can simply write x under root of x to the 25. Okay, and I'm just again writing different forms. Any one of them is already a good answer. Okay, this is a good answer, this is a good answer. Further, you want to simplify, you can write x to the 12 root x. I'll only explain that orally, try to understand. X to the 25 is x to the 24 plus 1, right? Under root x to the 24, when you take it out of the root, is x to the 12, 24 divided by 2. And then still there is one more x, right? X to the 24 times x. That one more x which is unpaired stays under the root, which is very much meaningful. Okay. What is a simplified answer? An answer that easily makes sense to us is a simplified answer. Okay. 3 to the 4 times 9 and sixth root of that. So whenever I see an expression like this, I have to always think, can I combine them in some way? Is there any common base that you can use or common exponent that you can use? Okay. You have to think like that. And it doesn't take much time to realize that 9 is basically 3 squared, right? Power of 3. And that becomes our starting point. So we'll see what to do with the sixth root later. But for now, let's go with this. 3 squared, right? Now, if you have the same base 3, you can add those exponents, 4 plus 2. So this is basically sixth root of 3 to the 6. Cancel it. That's 3. Okay. Now you are taking an even root, but actually I should write a little bit more here. Because this is an even root, you should say plus minus 3. Okay. Oh, my bad. Sorry. We would say plus minus 3 if we are solving an equation with x to the 6 equal to 3 to the 6. Sorry. Okay. I misspoke there. If you have, if there is no minus sign here, that means it's only the positive root. Okay. Just the regular root is the positive root. So it is only 3, not plus minus 3. Okay. Moving on. We are now looking at the graphs of the power function. Okay. Two cases only we have to discuss in general. And for our understanding, we can use the smallest powers like cubed and square as our basis. Okay. X raised to the any even power will have a graph looking like this. Now, where do you see this graph? That is a typical graph of y equals x squared, right? So any even power of x will have a similar shape, basically. It is important to note the exponent is greater than 1. Okay. So we're not talking about we are not talking about x to the half. Okay, that will have a downward facing, we will see that in a second. That will be root function, not power function. So by power, we mean power greater than 1. Okay. And what will be the difference between x square or x to the 4 or x to the 6? It could have been x to the 4, could have been x to the 6, and so on, right? The difference is you will get more and more flatter base here for large x, large exponent. Okay, I'll write that here. Flatter for larger exponents. Otherwise, they all look that U shape. Higher power, more flatter base. Okay. Similarly, if you raise to an odd power greater than 1, again, not x to the 1/3, okay, that will be cube root, we're talking about x cubed. So this could be something like y equals x cubed or x to the 5 or x to the 7 and so on. Okay, raising to an odd power. And what is the difference now? If your x is raised to an odd power, negative x to the power b will be negative x to the power b. Odd function, right? As a result, you will see that on the negative side, the output is negative. On the positive side, the output is positive. That is in contrast with even power, where whether x is positive or negative, the whole power is still always positive. Okay. Here I could have written minus x to the power b equals x to the power b when it is even. And when it is odd, it is negative x to the power b, hence that shape. Okay. Again, the same idea. If you have a larger power of x, this would be more, that region would be more flatter. So it will look more steep. Okay. For example, x to the, let's say 1001 would be something like this, like that, more flat around the 0. Okay. All right. Those are regular higher powers of x. If your exponents are between 0 and 1, we call them root functions. Okay. So if you are taking an even number root, like x to the half or x to the 1/4 and so on. Okay. Then notice this, okay, your graph is only on the right side of x-axis, on the right side of y-axis towards positive x-axis, because you cannot define negative under root of negative x, right, or negative number. So you can only define it for positive numbers and you get that graph. And noteworthy thing is that, and you can write the domain is only from 0 to infinity. Okay. Or in other words, sometimes we put this condition x is equal or greater than 0. So whatever is under the root should be equal or greater than 0. And you can see that the function is still increasing. One more thing I would like to point out here. The function is going to be increasing, but slowly. Compare that with x squared, right? This is x squared. This is under root x. Both of them, the function is increasing, but x squared will increase fast, right? Under root x will increase slowly. Hence the increasing but slowly, more and more slowly. So it becomes facing down. Okay. Downward facing. I will even write that because we will be talking, or I think we have already talked about it as well. This is downward facing. It is called concave down. Okay, whereas x square is upward facing. All right, I'm trying to recall and discuss, as many features as you can see in the graph. Whereas if you do the same thing with an odd exponent, right, odd root, you can define for negative numbers as well. So you see it on the negative side also. It grows. On the right side, you can see it similar to even root. Only difference is now it is also on the negative side. So for example, cube root of negative 8 is negative 2. Okay, cube root of 8 is 2, cube root of negative is negative 2. Hence you can see it is symmetric with respect to origin also, at equal distance from origin on the two sides, at equal angle, and you get two corresponding points. Okay. And now what if we combine them? Okay. So here's an example. You take an odd root after raising x to an even power. Okay. Because you have raised x to the even power, whether x is positive or whether x is negative, x square is positive, right? X square will be positive in both cases. And because x square is positive, you can find its cube root, which will be a positive value, and hence you see this graph, both sides increasing. X square is positive. Okay. And so on. Like, I mean, we're just discussing like different possible cases here. Okay. Those are all parent function or just the functions of x, raised to n power. We will now look at general polynomials with the root sign, right, under the root. Okay. So we are going to find the domain of those functions which are under the root. And what is our logic? Logic is very simple. The radicand of an even root function must be non-negative. Okay. Radicand is the quantity under the radical sign. That must be non-negative. Just as we already earlier said that for the graph of under root of x, here we said that the domain, x is equal or greater than 0, right? Now apply that to a general function. So to find the domain here, okay, solve this inequality. 9x plus 8, which is the radicand, equal or greater than 0. And that gives you 9x equal or greater than negative 8. You change the side. Now you divide by 9 on both sides. Negative 8 over 9. Okay. And so you say, therefore, domain is x such that x is equal or greater than negative 8 over 9. You can write like that. If you want to write in an interval notation, you would write negative 8 over 9 to infinity. Okay. Next, what is the domain of fourth root of negative fourth root of 2 minus 0.5x? Firstly, the negative sign here has nothing to do with the domain. It has something to do with the range. Because the sign is negative, I'll tell that here, the range will now be all negative numbers. So the range will be all everything from negative infinity to 0, because there's a under root sign, at the most you can go to 0. That's the effect of the negative sign on the range. As far as domain is concerned, you only focus on the radicand. Okay. Clarity, concept has to be clear. Okay. So what do we get? Solve that inequality. 2 minus 0.5x equal or greater than 0. Right? 2 equal or greater than, take the 0.5x to the other side. Or if you want to keep the x on the left, generally I advise that, okay? Keep the x on the left, so minus 0.5x equal or greater than minus 2. Okay, 2 is changed to the other side. Now you divide by negative 0.5. This time I'm going to show it clearly so there is no confusion. Divide both sides by negative 0.5. What happens? This inequality should flip. Those are the rules of inequality, right? If you divide by a negative number, you change the sign. So this implies x will be equal or less now. And negative 2 divided by negative 0.5 is 4. Okay, x is equal or less than 4. And therefore you say the domain of y is negative infinity up to 4. Okay, all right. What is the domain of 7th root of the same function, 2 minus 0.5x? All that you have to observe is it's an odd root. Okay, and that means there is nothing about that function, it's a polynomial. Okay, so the domain of that function g of x will be negative infinity to infinity. You can find odd root of any value of under the radical, right? So negative infinity to infinity. Okay, some more practice problems. Here is a graph which clearly is a graph of a root function, right? I hope you can see that easily from the shape. Okay, if it is growing slowly, that's a root function. If it is growing, for example, if it was like that, that would have been a power function. Okay, if it is increasing faster, it is power function, or decreasing faster, whatever way. And if the rate of change is fast, it's power. If it is getting more horizontal, more over a period of time, it is root function. If it is getting more steep, more vertical, that is power function. Okay. All right. Now we have that root function. We will write the domain and range and where is it increasing, where is it decreasing. First, we will discuss that. Okay. Look at the graph, zoom in, and you can see this is at the point 4. Okay. And I'm going by the assumption that this is an open circle here. It has not been specified. So I'm going with that. Okay. It doesn't look like a solid dot there, so I'm going with open. If that's open, then the domain is starting from that to the left, right? So from negative infinity to 4, not into that. And what's the range? Look at the y values. It's growing, decreasing slowly, but eventually it will decrease. Okay, it's slow, but it will go on decreasing. So all the way from negative infinity to 0, right? The y value. Increasing. Now, increasing and decreasing, you always have to see from left to right. And if you see from left to right, it is always increasing. So where I will say entire domain. Which is basically you can write the same answer. Okay, it's increasing in the whole domain. That means clearly it is not decreasing anywhere. Empty. Okay. Equation. Now an equation of that function is quite interesting. Okay. I'm not getting into how the equation will be derived because we have studied that in the previous chapters. Please go back and watch those videos. You have to figure out what reflection, what shifting, and what stretching, if any. 3 things, right? Reflections, shifts, and stretchings. If you take into account all those things, you can write the equation. I will write the final answer for you. It is a fun exercise for you to try and figure out the equation by yourself. Okay. I'll just briefly say what is being done here. The graph is reflected on y-axis. Its original function is root x, which should be facing to the right. This is facing to the left. Um, so it is, there should be under root of negative x. Okay, that is reflection on y-axis. But it is not just that. This one is facing, the given graph is like that. It's below the x-axis. So that is reflection on x-axis. Both reflections are there, okay, on y-axis and x-axis. And what else? It is not just negative x, it has been shifted, right? 4 units to the right, x minus 4. And the stretch factor, you will have to work to figure it out, is under root 2. Okay, divided by under root 2 or 1 over root 2, however you see it. You can take one of the points in the equation and try to verify that this is indeed the case. Okay, I will not dive more into that. Moving on. Use the transformations and explain how the given function can be obtained from the graph of the square root function. Okay. So my sequence of steps is what we will write, but before that, I'm going to show you how this can be simplified. Okay. Because you might think that x is multiplied by 4, so that should be some kind of stretching, right? The vertical stretching, but it's not 4 times. Okay. The reason being that we're talking about the root function, not x, under root x. So you should split that 4 out as a factor. So you factor out the 4. In parentheses, you have now x plus 4, and the whole thing is under the root sign. Okay, plus 4, which can be then written as the under root 4 can be taken out of the root, 2 under root x plus 4 plus 4. Now you can write the sequence of steps. Okay, so imagine like your input, the first machine, your input is x. Okay, what did your input was x, I'm not writing about, let me write here, flowchart. Okay, x was fed into this machine. What did this machine produce? First, x plus 4. So your first step in the sequence of step number 1 is left shift, right? Adding plus 4, so left shift by 4 units. Okay. Um, or you can think of it this way also. It was the under root function. Okay. So let me think in terms of the under root function. Okay, let's keep the under root there. Okay, that is left shift by 4 units. Then what was done? You can go with this, right? Now that is multiplied by 2. So from here you get 2 times under root of x plus 4. So multiplying by 2 like that, the step is vertical stretched by a factor of 2. Okay. And after that, 4 is added outside, right? That is added to the y value. So upward shift 4 units. Okay, so that what I showed here is a very nice strategy you can follow to come up with this sequence of steps that transform a parent function into the given function. Okay, so you have to think, what should I have, what should that under root of x become in successive steps until you get this final form. And most of the time you can see the sequence is natural. Okay, um, you can at first add 4, right? Or maybe you could have, okay, you could have maybe first added 4. um, but let's say between, vertically stretching and left shifting, first you shifted left by 4 and then you vertically stretch by a factor of 2, right? That you have to do in that sequence. Okay, maybe the outside plus 4 you could have done earlier or later, that would not matter. Or it would actually. So what we did is the correct sequence. If I earlier added 4 first and then later multiplied by 2, that 4 would become 8, right? So even that is also important here. So yes, you can see, as we naturally try to convert from the parent function, which is the square root x here, into the new function, you will get a particular sequence of steps. Sometimes they're interchangeable, but um, sometimes not. In this case, they are not. We have to follow exactly that sequence. Okay. All right. Two more problems, and then I will be um, ending this video lesson. In the next video, I will continue with the rest of the chapter. Okay. In these two problems, we are simplifying in the first and finding the domain in the second. What are we doing? There is exponents, fractional exponents, and the bases are 25, 125. What comes to our mind? Can I make them into the same base? 5 squared to the power negative 3 over 2. Okay. Why did I do that? Denominator is 5 cubed. Okay. Now, how do you know that? You might ask, you have to have some, like, basic knowledge, I would say, otherwise always you can go ahead and do the division. 5 can divide anything with ending with 5, right? You divide by 5, you get 25. Okay, then immediately you realize it's all divisible by 5. So you get 5 cubed equals 125. And again, why? Where am I even getting that thought from? Because I want to simplify using some laws of exponents, and it is really convenient if the bases can be same. We know that, right, in the exponents. Hence, and when I notice 5 and 5 ending with both numbers ending with 5, immediately I'm thinking, can I separate some 5 out of it? So try to express in terms of 5. Okay. Once you do that, the next step is to try and simplify each of them. So you can cancel the 2 and 2 because you have to multiply those two exponents, right? So you get negative 3. In the denominator, there is nothing you can cancel. So just multiply 3 times 1 over 2, 3 over 2. Now I want the final answer to have positive exponent. So let me take the numerator to the denominator because that has the negative exponent. So 1 over 5 to the power 3 over 2 plus 3 in the exponents. Okay, 3 over 2 plus 3. And that can be written as 5 to the 3 over 2 plus 6 over 2, which will be 9 over 2. Now, like before, I'm going to give you a number of answers. This is one perfectly acceptable answer. You can simplify it and write it as square root, right, of 5 to the 9, which is also fine. Okay. Or from the square root of 5 to the 9, you can take out 5 to the 8 from the root, right? That becomes 5 to the 4, which is 625 out of it. And 1 5 is remaining still. So 625 under root 5. If you ask me, the last answer is most simplified because it's most meaningful. Okay, it gives me a very good idea of what the number is. Okay, but technically, all of these are acceptable answers. Okay, next question. Determine the domain of the function sixth root of 4 minus x squared. Think about it. The key lies in the root there. It's the sixth root. Okay. So an even root implies, what did we say earlier? The radicand must be non-negative, equal or greater than 0. Okay. So 4 minus x square equal or greater than 0. Minus x square equal or greater than minus 4. 4 taken to the right side. Now you have both negative signs. You can simply flip them or multiply by -1, So you change the sign, x square equal or less than 4. And we should know it from previous lessons in this course. Okay. If x square is equal or less than a positive number, then it means negative root of that number is equal or less than x is equal or less than root of 4. But I will again explain what was the logic, right? I would have explained then also. If the square is less than a number, okay, then on the positive side, the number is less than the under root of x is less than the under root of 4. On the right side, it makes sense easily. Okay, x is equal or less than root 4. On the left side, what happens is, you have to remember, whenever you take negative numbers and square them, you will get the positive number. So x could have been negative as well, but how far negative? The logic is, how far I can go positive to the right side, only to that extent I can go on the left side. Okay, think of a number line. On a number line, if you are saying that x has to be equal or less than 2, it's confined to this length from 0, and you are going to square that number anyway, you could as well have gone on the left side, because by squaring it would anyway be positive. But how far left can you go? The same distance, right? Which will be -2. Hence, negative under root 4 is equal or less than x is equal or less than under root 4. Okay, you have to think like that. Okay. So that gives you -2 equal or less than x equal or less than 2, which itself is a good answer to write. Okay. So that's the domain. Or if you want to write in interval notation, you can say from -2 to, okay. All right. I will stop there. Thank you. I'll see you in the next video, where we are going to talk about these functions, the equation of a circle, which will end up becoming a root function. It is related. Hence, it comes in the under this topic.